Okay, so today we're going to talk about 3.1 quadratic functions. We've already looked at how to graph quadratic functions or parabolas using our transformations of a graph. Now we're going to look a little bit more at the key characteristics of our quadratic functions. So it gave you some background information here. Some of the things we're going to really talk about are axis of symmetry, the vertex, and then again talking about our maximum and our minimum. So remember, it's a metric across a vertical line called the axis of symmetry. So when we graph our quadratic functions in vertex form, we have the quadratic function f of x equals a times the quantity x minus h squared plus k, where a cannot equal 0, is in vertex form. The graph of the function f is a parabola whose vertex is the point hk. The parabola is symmetric to the line x equals h, and if a is greater than 0, it opens upward. If a is less than 0, the parabola opens downward. So we have some steps that can help us figure out what we're doing. So first thing, determine whether the parabola opens upward or downward. So remember, this is going to be if a is positive, we're up. And then if a is negative, we're facing down. Okay. So determine the vertex of the parabola. The vertex is hk. And there's two ways we can do this. We can either use the idea that we're going to change the sign of the value inside the parentheses. Or we can use our vertical and horizontal translations. I'm okay with you using either one. Use whichever one makes most sense to you, and we'll talk about using both of the methods when we do the examples on the next page. Okay, so then we want to find our x-intercepts. So when we find our x-intercepts, we're going to be solving f of x equals 0. Because remember, when we look at our x-intercepts, that's when y is 0. The function's real zeros are the x-intercepts. So remember, zeros, intercepts, and roots are all the same thing. Usually when we're in vertex form, we're going to be solving using the square root method. Okay, solve using the square root method. And then we're going to find the y-intercept by computing f of 0. So this means we're going to be letting x equal 0 and simplify. Okay, and then we're going to plot all of those points, and then if needed, we are going to add any additional points, and we'll be able to do that by using our axis of symmetry and doing reflections. Okay. So our example, first one we're going to do, graph the following quadratic equations, determine the domain and the range of each function. So first step, looking at our function, f of x equals -2 times the quantity x minus 3 squared plus 8. We need to figure out what our a value is. Here, a equals -2, which means that we're going to be facing down. Okay. Our second step is to find our vertex. So we can either look at our equation. So we have inside x minus 3. If we change the sign of that, that becomes +3. And then the 8 on the outside stays the same sign. Or use your translations. We know when we subtract on the inside, this is going to move right 3 and then up 8. If you graph that, up or right 3, up 8, that gives you that ordered pair 3, 8. Okay, so again, whichever method you need to think about it, I'm perfectly fine with. Do what makes most sense to you. All right, now we're going to find our x-intercepts. So we're going to set this equal to 0 and solve. So first thing we're going to do is we're going to subtract this 8 to the other side. So negative 8 equals negative 2 times the quantity x minus 3 squared. Divide by negative 2 on both sides. So 4 equals the quantity of x minus 3 squared. And to get rid of a square, we're going to square root both sides. But remember, when we take the square root in an equation, we have to put plus or minus in front. So we're going to have plus or minus 2 equals x minus 3. And then add 3 to both sides. So x equals 3 plus or minus 2. So if we break that apart, x equals 3 plus 2, which is 5. And x equals 3 minus 2, which is 1. So our x-intercepts are 5, 0, and 1, 0. Okay. Lastly, we want to find the y-intercept. And this is when we're going to evaluate the function f of 0. We have negative 2 times 0 minus 3 squared plus 8. 0 minus 3 gives us negative 3 squared is 9. So negative 2 times 9 plus 8 gives us negative 18 plus 8, which is negative 10. So our y-intercept is the ordered pair 0, negative 10. So I'm going to go ahead and plot these points. So we have our vertex already graphed. We have our x-intercepts at 1 and at 5. And then our y-intercept at negative 10. Okay. I'm going to add in one more thing. Let's add in our axis of symmetry, which is our line that goes through the vertex. And I'm going to draw it as a dashed line. Okay, this is our axis of symmetry. And it's x equals 3. It will always be the same as the x value of our vertex. So now we can finish off our graph. I'm going to find a fifth point. So I'm going to take this y-intercept and I'm going to count to the line. That'd be 3, and then count away from the line. And now we have 5 points to make our graph. Okay. And then it also asks us to find the domain and the range. So we know domain of a quadratic function is negative infinity to positive infinity. And then the range, since we have a maximum or a topmost value, we're going to go from negative infinity to 8, because that's the y value of our vertex. Okay. All right, I want you to try B, and then we will go over it tomorrow.